All right, guys, so we are literally at the end of Unit 7, and this last lesson is about solving rational equations. And our goal is we've been focusing on numerators and denominators for Lesson 4 when we're adding and subtracting um, these rationals, these fractions. And what our goal is for today is to solve rational equations. So our what we have to keep in mind is we would have two or more rationals, and there's going to be an equal sign, and then on the other side there's going to be this other rational, and our goal is to ensure that denominators are the same on the left of that equal sign and on the right. So the first step, part of that, the first thing that we need to figure out is ensuring we don't have to factor anything. So factoring is a key concern. All types of factoring is a key concern. So we might have to factor denominators at times. So we always want to make sure we look at our denominators first when we're starting this process. I haven't explained it, but when we're starting the process, we want to look at denominators first, figure out if we can factor them, and in order to meet our end goal, which is to make them the same so that they can be eliminated. So if we can do that, we can get denominators the same when we're solving for rationals, we can eliminate them and focus on an Algebra 1 concept of solving for a variable. But just looking at the differences, the comparison between the things we've done so far and what we're going to do today. The things we've done so far, we've simplified rationals, we've multiplied rationals, we divided, added, and subtracted rational expressions. This problem starts with no equal sign. There's a number of different ways to approach it, but the answer should end with no equal sign. So that being said, below, simplifying the following expression, 2x plus 3 over 8 plus 3x over 8, this is, we're adding rationals. So we're going to simplify a little bit and make sure our denominators are the same, and they are. That's 8 on the bottom. But up top, we can place these together. We can place those numerators together, 2x plus 3 plus 3x's. And then we just focus on combining like terms. Remember, I said to scratch them out or mark them out so we don't use it again. All right? When I'm done, plus 3, my answer is 5x over 3. 5x plus 3 divided by 8. Now, when you're solving equations, if the denominators are the same, first of all, there's an equal sign. That's how I know I'm solving. And the great thing about solving rationals, if I can get the denominators to be the same, I can mark out the denominators and just treat it as an Algebra 1 problem where I want variables on one side of that equal sign and numbers on the other side. So if I'm treating this appropriately, I'm going to move the x terms together. As I do that, 2x minus 2x goes away, 3 comes down, equals 1x, and that's just x equals 3. And like I said before, you end up with equal sign, a variable equals a number. So checking for the next two, let's solve the following rational expressions. Both denominators are the same, so I can eliminate them. This is the elimination process. I can eliminate same denominators, same, put DE in, okay? And I can proceed with solving this algebraic expression. There's not a lot I need to do here. So plus 5 on both sides, because I have the same denominators. I can eliminate them. That's just a rule. It's an axiom. My final answer is x equals 6. Look at the next one. The denominators are the same, so I can just eliminate them, and I'm left with the quantity of x squared plus x equals 2. Now, because I'm dealing with a quadratic, for 2 degrees or higher, more than likely I'm going to have to factor. You have to factor. So that means everything goes in standard form. Everything goes in the standard form. That means things move to one side. So I'm going to move the 2 over here, and it becomes x squared plus 2 plus x minus 2. So when I do standard form, I'm looking for two numbers, and we're going to put a little 1 in front. They multiply to -2. They add up to +1. So I know 1 and 2 would work, and if it's going to be positive, then 1 has to be negative, and that gives me a +1 if I add. So this equals x minus 1 times x plus 2. That means x for x minus 1 equals 1, the opposite of that factor. And another solution is -2. So what I'm going to do, what I'm going to ask you to do is to just go back and check, is the statement true? Does x squared plus x, what we don't want to end up with is a situation where we have a number over 0. This implies, if I end up with this situation when I'm doing a check, this implies that there exists an extraneous solution. This is a solution that you can solve for, but it doesn't work when I plug it back in. Okay? So x squared plus x over x minus 1 equals 2 over x minus 1, right? We're going to check that for x equals 1, and then we're going to go back and check for x equals 2. All right? So x squared plus x over x minus 1 equals 2 over x minus 1. All right? So plugging this in, I have 1 squared plus 1 over 1 minus 1 equals 2 over 1 minus 1, right? So 1 squared plus 1 is 2 over 0 equals 2 over 0. So this doesn't work. This produces, so this is what I know. X equals 1 is an extraneous solution. So it doesn't work. It's not effective, right? But on the other hand, let's check x equals 2. So 2 squared plus 2 over 2 minus 1 equals 2 over 2 minus 1. So 4 plus 2 over 1 equals 2 over, sorry, that's -2 here. And sorry, I did some inappropriate things here. So my other solution is not x equals 2, it's x equals -2. So be able to catch your mistakes like I did. So -2 squared plus -2 over -2 minus 1 equals 2 over -2 minus 1. So that's going to give me 4 minus 2 over -3 equals 2 over -3. So I'm going to swing that negative up for both of these. And I have -2 over 3 equals -2 over 3. So x equals 2 is the only solution here. So the only time you produce extraneous solutions, these solutions that don't work back in the problem, is when you get these answers that don't work. When you get two unequal answers, and when you get answers such as this one, where you have a number divided by 0. Okay? So definitely check this when you're factoring. Definitely go back and check your solutions when you're factoring. So what are the methods to solving irrationals? The first method is to make sure the denominators are the same. Okay? So that means you want to go look at your denominators. Look at each one and ask yourself, can you factor them? So the first thing we want to do is factor each denominator. And they did that for us. These are, so x doesn't have any other common factors. There's nothing I can do to x, so I just bring it down. Now x squared plus 2x is factorable, and I can bring out an x, and I'm left with x plus 2, this quantity inside of those parentheses. Now what this allows us to do is to find the lowest common denominator, or lowest common multiple. Okay, so what's missing from this side that this side has? I'm missing x plus 2 over here, so I'm going to multiply that on both sides. That's what they did. Okay, and what I do to one part of one side of an equation, I have to do to the other side. So if you notice, they did that to the other side. So this is multiply the numerator and denominator of each fraction to make sure each denominator is the same as the lowest common denominator. All right, so we did that. Once all the denominators are the same, set up an equation using the numerator of each fraction. So we're going to use the top of each fraction. And essentially what I said before, basically what they're saying, eliminate all denominators. When all denominators are the same, okay, when all denominators are the same, we eliminate all denominators. Okay, so then we're able to solve for this variable. We're at an algebraic situation here. All right, so the first thing we're going to do is to distribute. So 15x, 15 times x is 15x, plus 15 times 2 is 30, plus 9x squared minus 7x. That's the left-hand side. On the right, distributing, I have 9x squared plus 9x times 2 is 18x's. All right. Now, I'm going to simplify. I'm going to put 9x squared. I'm going to subtract 9x squared on both sides from those terms. They go away. All right. That means I'm left with, on the left, 15x plus 30 plus, minus 7x's. On the right, I have 18x's. So the next step I'm going to do is I'm going to combine like terms before I move on. So 15x's minus 7x's, right? 15x's minus 7x's gives me 8x. The plus 30 just comes down. Plus 30 comes down. On the other side equals 18x's. Now I just need to get like terms on the same side. So the best situation or step I can take is to subtract 8x's from both sides. And I get 30 equals 10x's. Divide both sides by 10. And x equals 3. Now, what they want you to do is to go back and check to see, make sure you don't end up with an extraneous solution from your original problem. So we have 15 over x, sorry about that. We have 15 over x plus 9x squared minus 7x, all right? 15 over x plus 9x squared minus 7x over x squared plus x equals 9. So I saw that x equals 3, so that's what it said. So 15 over 3, that's 5, plus 9 times 3 squared minus 7 times 3 over 3 squared plus 3 equals 9, question mark. We're checking to make sure both sides equal each other. So that's plus, right here, my fraction, 81 minus 21 over 9 plus 3 equals 9, right? So 81 minus 21, so 5 plus 81 minus 21, that's 60 over 12 equals 9. Let's make sure I wrote this correctly. I'm going to go back up and just check my information here. X times 15 over x, 9x squared minus 7x, right? Okay, and if I put this in my calculator, I get 5 plus 5 equals 10, equals 9, equals 9. Now, ask yourself, is it true? Does 10 equal 9? No, it does not. So you might want to just be careful here. X equals 3 is an extraneous solution. It does not produce the answer intended. It's an extraneous solution. So you might want to be careful. This is an instance of an extraneous solution. This is an example. Moving on, method 2 simply involves a little bit more tedious steps. We're not going to solve the problem from the way we did before, but all the way anyways. But this one, what you're going to do is factor the denominators, okay, in each fraction. Find the lowest common denominator, right? And then multiply each fraction by the lowest common denominator and cancel out what you can. And what happens is you end up with canceling these x's, 15 parentheses x plus 2. The x's cancel, the x plus 2 cancels here, plus 9x squared minus 7x's equals 9 times x plus 2. And we're pretty much back at the same situation we were before, and you just solve for x from there. But we're not going to spend time with that problem. We're going to go on to the next. So we're going to go on to solving problems. So things we want to do: factor denominators, right? Number 2, we want to find LCD. 3, make all denominators the same. 4, eliminate denominators. 5, solve for variable. All right, so I'm going to make a little note out here. LCD here, lowest common denominator. So my lowest common denominator is going to be, there's no factoring here. It's going to be 4n times 5. It's going to be 20 n's. It's going to be 20 n's, period. Don't have to worry about factoring here. So in order to make 20 n's on the bottom, I need to take this number, 5, and multiply it on the top and the bottom, right? And over here, I need to take this number, 4n's, and multiply it on the top and the bottom. That's the first step. So that's number 1. So I'm going to simplify from there. I have 5 parentheses n minus 6 over 20n's equals 2 parentheses 4n's over 20n's. Okay? Now, I'm going to do a little bit of simplifying here. These are the same, so I can eliminate them, but here I'm going to distribute 5 n's. 5 times n is 5 n's. And then 5 times negative 6 is negative 30. Equals 2 times 4 is 8. And n just drops down. Now, we want to make sure n's are on the same side. So we're going to subtract 5 n's on both sides. Negative 30 comes down, equals 3 n's. Divide both sides by 3. And n equals negative 10. There's my answer. Okay? Now, the next problem. We want lowest common denominator. And we have x and 3, and then we have 3x. So if we put those together, we can end up with 3x here. So what's missing from fraction 1? We're missing a 3. From fraction 2, we're missing an x. And from fraction number 3, we're missing nothing. So we're going to rewrite that. So 3 times 1 is 3 over 3x's, plus 1 times x is x over 3x's, equals 8 over 3x's. Now I can go back and eliminate these common denominators, and I get 3 plus x equals 8. Subtract 3 on both sides, and x equals 5. Next, what do I need to have a common denominator? I need 3x all the way across, so my lowest common denominator here is 3x. So I'm just going to create a fraction here and multiply it times 1. What I end up with is 3x over 3x plus x squared minus 5x minus 24 over 3x equals x minus 6 over 3x. Now I can eliminate denominators because they're all the same. And I end up with 3x plus x squared minus 5x minus 24 equals x minus 6. Combining like terms on the left, 3x's minus 2x's is negative 2x. And I'm going to rewrite this in standard form with the leading x term first. All right, but for the time being, I need to simplify. So how do I deal with this type of problem when there's a degree more than 2 for this problem? So I'm going to subtract x's on both sides, and I'm going to add 6. I'm going to do the opposite. So subtracting x's and adding the numbers 6 to both sides. I'm skipping a step here. I get negative 3x plus x squared minus 18 equals 0. So I'm just going to rewrite this to standard form. So x squared minus 3x's minus 18. So remember I said before, when you get in this situation, you want to factor the polynomial to get the factors. You get the factors, then you can get the solution. So I'm going to make this smaller here so I can do the work that I need to. All right, so let's bring this up here in standard form. So I want to know what two numbers multiply to negative 18 add up to negative 3. So I could try 1 and negative 18, that gives me negative 17. Should try 2, negative 9, that gives me negative 7. 3, negative 6, and that gives me negative 3. So there's my factor. So I have x minus 6 times x plus 3. Now, my solutions, because of those factors, is x equals 6 and x equals negative 3. So I'm going to erase, and we're going to go back and check. I'm not going to do this for all of the problems, but we're going to go back and check to see if one of these numbers, one of these solutions, makes the solution extraneous. All right? So looking at those two solutions, do I produce, or is one of these going to be an extraneous solution? So I have 1 plus Let's see, 6 squared minus 5 times 6 minus 24. Up top, divided by 3 times 6 equals 6 minus 6 over 3 times 6. So I have 1 plus the top 36 minus 30 minus 24. So it's 36 minus 30 minus 24. If you can't do the math in your head, you probably should go to your graphing calculator here. In the meantime, I'm going to check out the bottom parts while I'm waiting for that to come up. Right? So I'm going to put this in my graphing calculator. I have a second mode here, 36 minus 30 minus 24. Enter. And I get negative 18. Okay, equals 0 over 18. So that's 1 minus 1 equals 0, or 0 equals 0. So 6 checks out. What about 3? What about 3? Negative 3. So I have 1 plus negative 3 squared minus 5 times negative 3 minus 24 over 3 times negative 3 equals negative 3 minus 6 over 3 times negative 3. So I get 1 plus whatever's up top, that's 9 plus 15 minus 24. So 24 minus 24 is 0 over 9 equals negative 18 over, no, I'm sorry, negative 3 minus 6 is negative 9 over negative 9. So I have 1 plus 0 equals 1, or 1 equals 1. So both of these solutions pan out. They work out. Okay? So you check 4, 5, and 6 on your calculators. But I'm just going to go through these. So I need common denominators. I have 2x, I have 4, and I have 8, right? So I know I need an x in all those denominators. So my lowest common denominator is going to include x, and my lowest common denominator is 8x. So I need to figure out how to get each denominator to be 8x. What do I need to multiply on each denominator to get 8x? So I'm going to say x plus 3 over 2x. That's one fraction. Plus 3 over 4 equals 5 over 8. So I need to produce 8x in that denominator. I need to produce 8x in the denominator. So I'm going to multiply the top and the bottom for the first one by 4. All right? And what does that look like? Well, we have 4 distributes to the x. I'm just going to go ahead and simplify. 4 distributes to x, and I get 4x. 4 distributes to 3, and I get positive 12. Over 4 times 2 is 8x on the bottom. Now, the next problem. How do I get 8x on the bottom here? What can I multiply by? So I have 8x divided by 4 equals 2x. So I'm going to multiply 2x on the top and 2x on the bottom. I get plus 2 times 3 is 6, and the x just comes down. 2 times 4 on the bottom is 8x. So I'm following through on getting those common denominators at the bottom. All right, using what I know comes out of the lowest common denominator. I get 5 over 8. I have the 8. I'm just lacking the x. So 5 times x equals 5x over, make sure you bring your equal sign down, guys, 8 times x. Now all my denominators are the same, so I can eliminate them. And I'm just at a common algebra system here. So combining like terms, 4x plus 6x's is 10x's, plus 12 equals 5x's. Now I want like terms on the same side, so I'm going to subtract 10x's on both sides. I get 12 equals negative 5x. Divide both sides by negative 5. And I get x equals negative 12 over 5, right? Make sure you're going back to check your answers. Next, I have 4y, 2y, and 6. So I need common denominators. So you could just see that 2 is a factor of 4. So definitely looking at what's lacking. 6 and 4 do have common factors, but I'm going to use 12y here as your lowest common denominator. 12y. Our goal is to get to 12y. So to figure out what I need to do, I'm going to multiply 3 over 3 to produce 12y here in the first one. So that gives me 3 times 2 is 6y's. 3 times negative 1 is negative 3 over 12y. For the next one, my goal is to get to 12y. So 12 divided by 2 is 6. Y divided by y is nothing. So I'm multiplying 6 over 6 here. So plus 6 times 1 is 6. 6 times 2 is 12. And the y just comes down. Lastly, equals 4 over 6y, 6. So I need a y term and I need a 2 to get 12, right? So we got to have our multiplication facts down. So 4 times 2 is 8y's over 12y's. All of my denominators are the same, so I can work on my algebraic problem here, right? 6y's comes down. Negative 3 plus 6 is positive 3 equals 8y's. Negative 6y's on both sides. And 3 equals 2y. Divide both sides by 2. Y equals 3 over 2. Now, for the last one, we need to factor this polynomial to see what's missing. So if we factor, we get 4 over x minus 2 times x minus 6, right? Equals x over x minus 2 plus 1 over x minus 6. And then it's obvious what's missing from each rational. Nothing's missing from the denominator of the first rational. So I'm going to multiply x minus 6 over x minus 6 over here. And then I'm going to multiply x minus 2 right here on the top and bottom. So this just comes down. This part just comes down. I didn't change anything. I have my lowest common denominator already because both multiples are in there. And then x times x minus 6, or x squared minus 6x on top. On the bottom, I have x minus 2 times x minus 6, right? Now, for the next one, it says plus x minus 2. 1 times x minus 2 is x minus 2 over x minus 6 times x minus 2, right? The denominators are the same. Didn't mean to do that. So my denominators are the same, so I can just eliminate them. Eliminate. Rewrite. I have 4 equals x squared minus 6x plus x minus 2. Combine like terms. I get 4 equals x squared. 6x plus 1 is negative 5x minus 2. Subtract 4 on both sides. We're working with a quadratic. And we get x squared minus 5x's minus 6. I need to factor this to find the extraneous solutions. So that's x minus 2. Find the solutions, not necessarily extraneous solutions. Times the quantity of x minus 3. So x equals 2, 3. Right? And we're pretty much done. You just have to go back and check. The next part that we're going to do is to do the Unit 7 review. So we're going to be doing a lot of practice there. But go ahead, watch the video. Hope you enjoy your day. I will catch. And also, please do homework number 5. It is due next class. If you haven't turned in homework number 4, there is a little bit of leeway in there, and you can turn it in the day we do the review. Your test is immediately, the day we meet immediately after we complete the unit review. Unfortunately, at this point in time, if you haven't turned in homework 1, 2, or 3, you do have a 0 for those particular homeworks. Have a great day. Okay.